Thank you for joining me on Project Statistics YouTube channel. Today we're going to talk about understanding hypothesis testing, significant level, test statistic, and p-value in research analysis. In this video, you are going to learn what inferential statistics mean and how it works in research. We'll also learn the concept of sample and population in research, what a hypothesis is and a null hypothesis, what hypothesis testing is and why it is important in research. And we're going to also discuss the four steps of hypothesis testing, the criteria for a decision, and also we're going to talk about the meaning of significant level and how to use it, including how to interpret test statistic. We are also going to talk about what a p-value really tells you in research analysis, how to make decision using the rejection zone and critical value, and most importantly, you are going to understand how to make your decision rule. So this video is packed with a lot of information, and I want to encourage you, whether you are using SPSS, you are using R, or you are using Stata, or you are just learning statistics, this video is going to help you to build a strong foundation in statistical decision making. So first of all, we're going to talk about inferential statistics. The principle of inferential statistics is based on the idea of using information from a sample to make a generalization or infer conclusions about a population. Since it is often impossible to study the entire population, inferential statistics allow us to draw probable inferences using data collected from a small group, also known as sample. So we use inferential statistics because it allows us to observe samples to learn more about the behavior in populations that are often too large or inaccessible to observe. So we use samples because we know how they are related to populations. Now, um, you know, as you can see in this diagram, we have a very large population in blue, and for us to study this population, it may be impossible for us to have access to the whole population. So what we do, we choose a sample. Now, a small sample we're going to choose, and then we're going to collect data from this sample and use it in our research. Then, after getting our result, we can now generalize the result we have as applied to the whole population. So that is the concept of sample and the population. Now, since the sample mean is an unbiased estimator of the population mean, if we select a random sample from a population, then on average, the value of the sample mean will equal the value of the population mean. So in research, we select samples to learn more about populations of interest. So in terms of the mean, we measure a sample mean to learn more about the mean in the population. Therefore, we use the sample mean to describe the population. On average, the value of the sample mean will equal that of the population mean. So the larger the difference or discrepancy between the sample mean and the population mean, the less likely it will be that the value of the population mean we hypothesize is correct. So we always begin by stating a hypothesis about the value of a population mean, and then we select a sample and measure the mean in that sample. Now, starting from a hypothesis, what is a hypothesis? A hypothesis is a statement or a proposed explanation for an observation or a phenomenon, or even a scientific problem that can be tested using a research method. It is often a statement about the value of a parameter in a population. It is a tentative or provisional statement derived from theory that can be either verified or falsified. It explicitly states the expected relationship between an independent variable and dependent variable. Now, having known what a hypothesis is like the claim, our expectation from a situation or an event. Now, we have to test the hypothesis. Now, testing the hypothesis is a method of evaluating samples to learn more about characteristics in that given population. Now, hypothesis testing is really a systematic way to test claims or ideas about a group or population. Okay, for illustration, suppose we read an article that the male students in a certain university tend to spend more money buying recharge card per week than the female counterpart. Now, this is a claim, this is your hypothesis that the male students in a certain university tend to spend more money buying recharge card than the female counterparts. To test whether this claim is true for a university population, we randomly select only 50 students, which represent a sample among all the students in the university, which is the population. And then we record the amount of money each of them spend on buying recharge card per week. So the mean we measure for these 50 students is a sample mean. We can then compare the sample mean for our selection to the population mean stated in the null hypothesis. Now, what it means is that since we can, let's assume that the population of the students is about 3,000, and you know you may not be able to have access to all the 3,000 students in the university. You may just select 50 of them and use them, collect data from those 50 students and use them to do your research. And at the end of the day, you get a result and generalize your results to apply to all the population. So that is what happened. Now, in hypothesis testing, also known as significant testing, is a statistical method for testing a claim or hypothesis about a parameter in the population using data measured in a sample. You see, you use the data measured in a sample to test the hypothesis about the parameters of a population. So this is very important because we are always using the data measured in a sample. In this method, we test the hypothesis by determining the likelihood that a sample statistic would be selected if the hypothesis regarding the population parameter were true. There are about 4 steps to hypothesis testing. The goal of hypothesis testing is to determine the likelihood that a sample statistic will be selected if the hypothesis regarding a population parameter were true. So the first step in hypothesis testing is to state the hypothesis. The second step is to select the criteria for a decision. And the third step is to compute the test statistic. The fourth one is to make a decision. Now, in step one, we state the hypothesis. There are 2 types of hypothesis, so to say. Now, you can see the hypothesis is in plural here. Now, the first type of hypothesis is a null hypothesis, and the second one is the alternative hypothesis. Now, the null hypothesis all usually states that there is no effect or no difference. It is a statement that contradicts your claim most of the time. A statement that contradicts your claim or your initial observation about an event. So your null hypothesis always contradicts your claim or your initial observation about that particular event. So the alternative hypothesis states what you want to prove. That is what the alternative hypothesis. So we begin by stating the value of a population mean in a null hypothesis, which we assume to be true. Now, this is very important. When starting a research, you begin by stating the value of a population mean in a null hypothesis. That means in a statement that contradicts your claim, and you assume that that statement is true. For the example of the student recharge card example, we can state that the null hypothesis that there is no significant difference between the recharge card expenses of the male and that of the female. So in this case, our initial claim is that male spend more money buying recharge card, but our null hypothesis will state that there is no difference between the recharge card expenses of the male and that of the female. So in step one of hypothesis testing, we state the hypothesis. This is the starting point so that we can decide whether or not the null hypothesis is likely to be true. Similar to the presumption of innocence in a courtroom, when a defendant is on trial, the jury starts by assuming that the defendant is innocent. The basis of the decision is to determine whether this assumption is true. Likewise, in hypothesis testing, we start by assuming that the null hypothesis is true. Now, the key reason we are testing the null hypothesis is because we think it is wrong. Now, look at it. You state a null hypothesis and assume that the null hypothesis is true, but you at the same time believe that it is wrong. That is why you are actually testing it, because you believe it's wrong, even though you assume it is true. So, in a courtroom, the defendant is assumed to be innocent. This is, of course, their null hypothesis, so to say. So, the burden is on the prosecutor to conduct a trial to show evidence that the defendant is not innocent. In a similar way, we assume the null hypothesis is true, placing the burden on the researcher to conduct a study to show evidence that the null hypothesis is unlikely to be true. There are two things that can happen when making decision that relates to null hypothesis. The first is that you make that decisions are made about the null hypothesis, and the second is that you do nothing. What that means is that, using the courtroom analogy, a jury decide whether a defendant is guilty or not guilty. The jury does not make a decision of guilt or innocence because the defendant is assumed to be innocent. All evidence presented in the trial is to show that a defendant is guilty. The evidence either show guilt and a decision of guilt is made, or not, and a decision of not guilty is made. In a similar way, the null hypothesis is assumed to be correct. A researcher conducts a study showing evidence that this assumption is unlikely. So we reject the null hypothesis, or fail to reject. We return the null hypothesis. So the second thing that can happen is that you do nothing. Now, using the courtroom analogy, for the same reason, the court will rather let the guilty go free than send the innocent to prison. Similarly, researchers would rather do nothing, or that means accept previous notion of truth stated by a null hypothesis, that than make decisions that are not correct. So, for this reason, we assume the null hypothesis is correct, thereby placing a burden on the researcher to demonstrate that the null hypothesis is not likely to be correct. So, but keep in mind, however, that when we return the null hypothesis, this does not mean that the null hypothesis is correct. Instead, it means that there is insufficient evidence to reject it. It is not possible to prove the null hypothesis. If you like this video, I want to encourage you to like, share, and subscribe to our channel so that you see more of our videos when we publish the next one. So look out for part 2 of this video.